In this video, we're going to work through visualizing maps using tmap, which really stands for thematic maps. So this slide here is just showing some of the breadth of maps that you can create using tmap. You can see we're starting to see shape files. We're starting to see rasters here at the bottom left. We're using, it's almost like we're faceting across a different variable here. If you're familiar with ggplot language, we see the scales here at the bottom, North Star scale, plot title. We have a continuous scale bar, grouped scale bar here. So lots of power and control that you have within tmap, and really extends beyond ggplot. So a bit about the package. It was first released on CRAN in 2021, but experienced a major upgrade in January 2025. So much of the syntax has really changed, and there are a lot of new features that have been added to the package. And what's amazing about tmap is it allows you to generate interactive as well as static maps. So this interactive feature, I think, is really the most the best parallel to GIS. It allows you to create a map in your view window, click on a certain geometry, or like for instance, click on the country, and then out pops this window with all of its attribute features related to that country. And you can then click on another spot in the world on a different geometry, and out comes a window and the associated attribute features related to that country. So really, really similar, I think, to GIS with that interactive feature to it, and point and click a bit more. So again, it's an easier way to visualize raster data as well. You don't need to convert raster data to a data frame for visualizing, like what we saw in when working with trying to visualize raster data with ggplot. So a bit easier there. Okay, so we're going to walk through the basic elements of tmap and start to build on top of it as we start to like work with the aesthetics and formatting and whatnot. So the basic elements of tmap, of creating a tmap or a thematic map, is to identify the map mode, whether that's a static map or interactive. You want to call the data, and then you want to define the data. So this is the example here. At first, we have tmap_mode, and within that parentheses, we're either going to put plot in quotes or view. Plot allows us to create a static map, just like we were working with ggplot. If we want to work with an interactive map, we would use view in quotes and put that into the parentheses in the function tmap_mode. Okay, so say now we're working with shapefile data, or a shapefile and SF object. This is where we would use tm_shape, and in the parentheses we would include the name of the shapefile. And then next we would include anything related to the data. So this is, I guess, the most similar, like I said here at the bottom, most similar to our geom. So say we had a shapefile of polygons, we would use tm polygons. Say we wanted to do points, we could use tm dots or tm bubbles. This is our, again, this is our geom. tm_raster allows you to work with rasters. Symbols, if you have points, polygons, or lines and you want to create symbols out of them. tm lines, again, a lot of power here. Depending on the type of data you're working with, you will choose the corresponding function. And this little table here is indicating those that are basic functions and those that are derived. So for instance, this tm_borders, you feed it the polygon and it only shows the borders. Doesn't create any sort of fill. The opposite, if you just want to show, this is really just in the weeds, but if you just want to show the actual shapes of the polygons and not their outline, their border, you would use tm_fill instead. And in the parentheses, you would include the name of the shapefile polygons. Okay, but big picture here, tm_ and whatever sort of function you're using is very similar to geom_bar, geom point, geom sf. Okay, so this is just an example that we'll walk through. So we have here, what you're not seeing is the line above, which should say tmap mode, and then in the parentheses we have plot, because this is a static plot. And under that we have tm_shape, because we're working with a shapefile, and we're calling it New Zealand. That's the name of this, or excuse me, NZ, which is the name of our shapefile, which is of New Zealand. And we're using tm fill for the first one. You see that there's nothing in there. We're just saying fill it. Generically going to be filled with gray. So that's what this first panel here is. If we use tm borders, we only see the outline. Everything else is empty, although it appears white, just like our background. And if we do tm_fill and tm_borders, we now have the outline of each of these areas within New Zealand, and each of them are filled gray in this case. Okay. Just like what we saw in ggplot, we can then start to play with different variables. If we want fill equals a certain variable, so we wanted to fill New Zealand and all those different regions by a certain variable, we can fill that with different colors. This is again very similar to the AES that we saw in ggplot. You can say for the tm_borders, we can make that color red. So you have a lot of power here in terms of what you want to express and communicate in your maps. So we're going to walk through another example here. First, I'm going to explain again some of what each one really corresponds to. So unlike ggplot, which uses the helper function AES to represent variable aesthetics, tmap accepts a few aesthetic arguments depending on a selected layer type. So fill, this is pretty self-explanatory, but fill corresponds to the fill color of a polygon, while col corresponds to the color of a polygon border, line, or point. The LWD argument corresponds to the line width. LTY is line type. Size would be the size of a symbol, and then shape of a symbol. We can also start to customize the transparency of either fill or color, and that's using fill_alpha. Alpha is, that term is what's used to help customize transparency of a color. So fill_alpha customizes the fill, while col_alpha emphasizes, or excuse me, customizes the color of like a line or a border. So the text here at the top just helps to create each of these panels here. Each line creates a different panel. So just walking through this, they're all calling on the same shapefile, which is New Zealand. And we're always using tm_polygons. In this case, we're saying fill equals red. We're saying fill each of those regions red. We're playing, the next panel, we're playing with transparency. So that's where we say fill_alpha equals 0.3. This ranges from 0 to 1. We've said 0.3, so it lightens it from this original red here. In the next one, we're saying make the color blue. Remember, col speaks to lines, borders of polygons, what have you, points. So that's why only the border is blue. LWD equals 3. We're playing with the line width of the border of these regions in New Zealand. Line type, LTY, equals 2. The number 2 just happens to correspond to dashed lines. So that's what we're seeing here in this panel. And then finally, in the last panel, we're combining a lot. So we're saying fill equals red. We're combining all of them, actually. The alpha is 0.3, so make it that pink color. The call, or the color of the borders, is blue. Line width equals 3, so really thick, as well as dashed. So that's what we're seeing here in this bottom panel. And this is just an added point to make. You can create all these different figures here, or maps here, and then you can arrange them in this little 6-panel set using tmap _ arrange. Okay. So just moving beyond the basics here. So again, this is what we've seen. We can start to build on, this is where we start to customize the scale a bit. So say we used TM shape, we said fill equals some sort of variable. We can now start to play with what that scale is. Here's where we would identify the scale, determines how the provided values are represented on the map, the legend, as well as if you are faceting or not. This is where you would indicate whether those scales are consistent across those facets. So this is ultimately what it would look like for each of those arguments. And just a few more points about how to customize a legend in tmap. You can define the legend title with the word title in quotes. The legend position, you would identify using the tm _ pause out if you want the legend to appear outside of the map. You can indicate it using both horizontal position, left, center, or right, as well as vertical position, bottom, center, or top. If you want your legend inside the figure, you can use tm _ pause _ in, and you can use the same arguments to identify where in the map you'd like the legend to appear. And then finally, you can also play with the orientation of the legend, whether orientation equals landscape in quotes again, or orientation equals portrait. This is only speaking to maps that you make with tmap that are static. Nope, I'm mistaken. You can play with this. You can play with the orientation for either view mode or static. So similar to what we were discussing when it comes to customizing the scale in ggplot, you can do that here. We touched on this in the previous slide, but this helps you to control the values that are represented on the map in the legend, and they are really largely dependent on the selected visual variable that you're using. There are some default settings in terms of how you wish your legend scale to be, the breaks of it. But you can also manually set these breaks as well using breaks, and the word breaks or argument breaks, and which sets the number of bins that you wish to include in your legend. And then finally, values is another argument that's used, and this defines the color scheme. So this is where you can include some sort of palette, and there again are hundreds of palettes that you can use. Okay, so just another example here. This helps us to look at, for instance, say we're going to fill each of those regions with this variable called median income. You can see that this is inserted, this argument is provided in quotes. That's very different from ggplot, where we did not use those quotes. So for the first panel here, this is just the generic output in terms of what the scale and breaks are, which is quite pretty. And I say that as that's the generic pretty breaks. The next one here, the scale is actually provided as far as breaks 0 to 30,000, 40,000, 50,000. So you see that here in this next panel, that there's only 1, 2, 3 groups here. The next panel here, there's a lot more breaks, and this is just showing that there's another way in which you can indicate how you want those breaks to be listed, and that's by identifying the number of bins that you wish to have, and in this case it's 10. So it finds a way to break up your data evenly to ensure that there are 10 groups. And then finally, playing with the value or the actual colors. This here is a predefined palette that you can use. Again, best way to find these palettes is to Google it. And this is just one of the blue-green palettes. So feeding it that name in quotes again knows, okay, you want this palette, and we can just change from blue to green. Okay, I spoke about this a little earlier, but there's some different styles that you can use within the customizing of scales. I'm working down here at the bottom. This is a lot of text, but I think it's all helpful to see. But I think what's most helpful is these different styles that you can use. Style equals equal, in quotes, divides the input values into bins of equal range. Quantile, that ensures the same number of observations fall into each category. Jenks, JENKS, identifies groups of similar values in data and maximizes the difference between those categories. And then finally, log 10 pretty. So depending on this takes a bit more on your end to understand what your data is and the distribution of the variable in which you're wishing to visualize, understanding the distribution of that and knowing how best you want to communicate, like what exactly you're trying to communicate. And this then will help you to identify which of the different styles you wish to use. So this is just showing you what, again, that same variable median income, what that looks like when you use these different styles in terms of how you break up your scale. And again, you can see that these maps look very different depending on what style you're using. So this, again, just to emphasize, depending on what you're trying to communicate, as long as you're transparent about how you're communicating your data, this is really helpful to ensure that your message is getting across and just representing your data the best way possible. This last thing is just to show you that depending on the data you're using, what your variable is, you can use TM scale continuous, and you have this continuous legend here on the left. If the variable that you're feeding it is categorical, you would be operating within a TM scale categorical. You can provide it 2 different colors to represent north and south, say if you wanted to change these colors, for instance. Again, this is just another example. We've also here added, this is where faceting is actually coming into play. So, and this looks very different from ggplot. So here in the TM underscore polygons, we've said fill, and we've said TM underscore vars, and we've fed it 2 variables that we're interested in visualizing. Pop underscore dense and pop 65%. In both of them, they have different legends, they have different they're actually different values as well. So it's not exactly as similar to facet wrap, which was the same value of data that's being visualized across variables. This is 2 different variables that are being visualized at once. So a little different from faceting, but it kind of looks just like a facet wrap if working with ggplot. Excuse me, but you can also see here fill.scale. and we've fed it this purples palette. So both variables are visualized in this purple palette. Okay, so just to wrap up here are some additional resources. The work that I've just worked, or the slide deck that I just worked through is actually built off some of these resources that I provided, but they provide a bit more detail in terms of operating and syntax and all that. So it's worth to look into.